This is the expression of geometric sum, and so this is a geometric series and this is the sum here. So this is the expression, we know it, and I will try to prove this one using mathematical induction when n is all positive integer. So what I will do, first I will start for n is equal to 1. When that happens, left hand side is basically just a and right hand side becomes a here. R to the power n is 1, so r minus 1 there, r minus 1 there, so it just gets cancelled, so it's just a here. So left hand side is equal to right hand side. Then we will go on to assume that when n is equal to k, where k is any positive integer, this relationship is true. So basically a plus ar square plus up to a r to the power k minus 1, so n is equal to k minus 1 is equal to a r to the power k minus 1 over r minus 1. So we are assuming that this is true, and then we will see what happens. So since we are using mathematical and induction method, this is the way to do. So when n is k plus 1, so the next integer, what happens there? So the left hand side now becomes a here, a plus ar square plus a r to the power k minus 1 plus a r to the power k, because k plus 1 minus 1 is just k, so n is k plus 1 now. That's it. Now this part is, we have assumed that this part is here, this one, so we can write instead a r to the power k minus 1 over r minus 1, and this one is a r to the power k, and then we will just do the addition here. So this is r minus 1, this is a r to the power k minus a plus this one multiplied by this one, so basically r a r to the power k and then minus a r to the power k. So this one is minus a r to the power k here, this is plus a r to the power k here, so these two get cancelled, and here we have something like this. So what we will do, let's write this one, this is minus a, this is plus a r to the power k plus 1, because here r to the power 1 here, and this is k here, and this one is r minus 1. So this one can now be written a here, r to the power k plus 1 minus 1, so I have taken the bracket, so like that. Now this is when n is equal to k plus 1, this is the right hand side, because that's the left hand side. When n is equal to k plus 1, we started from there and we arrived to something which is the right hand side when n is equal to k plus 1. So we have shown that the left hand side is equal to right hand side when n is equal to k plus 1. So using mathematical induction we have proved this relationship.